Alright, now we're speaking about RAM, and in order to measure the space complexity for the RAM, it's also called big O notation for that RAM. We need to find to have some kind of more understanding of how does it being calculated. So, in order to have a big O being considered, it is only considered when we're using extra spaces. So we kind of fuse the big O notation for RAM or space complexity when we're working with extra spaces and we don't work with what is given to us. It's kind of vague now, but we will see next what does it actually mean. So we're given an example here, and in order to have a better understanding of RAM and how does it work, we need to have an algorithm that can show us how can we use RAM effectively to be calculated. So we are given this problem, we want to find the least repeated character in this given list of characters. So we want to least repeated character in this list. So alright, so just by looking, find the least repeated character. Just you as a human being, just look it. We have 3 A's here, 1 C, 1 B, 2 D's, then another A, another B, and another A. So we know there is 5A, we know there is 1B here, 1B here, 2B, and we have 2D here and 1C. So the least repeated character here is C. So that's what is what's visible in front of us as a human being, like by look. So now we have this C, just the least repeated character because it only represents 1. The count of it is just 1. Now we need to find this problem by using algorithm. So we have a solution. The first solution in our example is gonna be by iterating, and every time we iterate we're gonna check for the other repeated characters that is the same as the first iteration, and I will show you how using this illustration. So we're having this current iteration, we're pointing at the first index at character A. We're gonna now iterate. If the same character plus a different position, we're gonna increment. So we already found a 1, which is basically the first A. So now we're gonna start by iteration. Another iteration that we're gonna check if the value of A represent at another index, and if it actually represents in another index, then we increment it by 5. So now let's increase our inner iteration, which is second iteration. So now we found another element, now we increment this one. It's not A, so we're ignoring not A, not A, not A. It's E and different index, B different character, A same character. So now we have found 5. That's for our current first iteration. So now for the least repeated character is 5A. So I'm not sure actually for this, but anyway, moving on. For the first character is 5A. Moving on for the second current iteration. Now we're gonna repeat the same process. Even so, we kind of calculated A. We already found all A's. We don't really care about it, but we are forced to iterate through the character again. So we're gonna repeat. So now we found 1. We're basically at this position, so we need to increment it by 2. So we keep doing the same process again until we reach the point where we looped another loop here. Now we're gonna finish our second iteration, and the current iteration increased by 1. And we're gonna repeat the same process for that A and so on. But I'm just not gonna repeat it because it kind of makes no sense. But you need to know that we should be making this A, the third A. Even so, it's pointless. So skipping to C here, we're gonna iterate so until we find C. we found C here, we incremented by 1. We're just gonna keep until we find another C, but since it doesn't really exist, so we're just gonna loop. We're taking more steps, just pointless step, just for the sake of this iteration. Now the least repeated character is 1C, because we know that we have found one which is smaller than this 5, so we're just gonna replace. Alright, so now the current iteration gonna move one step to become B, and then we're gonna go to D until we reach the point of A. And basically that's for the solution power 1. We're taking a lot of steps, which is very unuseful. It's pointless to have this kind of stuff. That's for solution number 1. So how does big O work for RAM? This is the same example as before. No RAM was used, which is good. We didn't really use any RAM. But by applying those steps for every character we iterated over the full list, we made unuseful execution steps. We made execution steps for nothing, absolutely nothing. We didn't really benefit anything. So this caused repeated steps, which didn't really help us. This algorithm runs in n times n, where n is the size of the list. That's for the worst case. And actually it's not really the worst case, it's the normal case here, because basically we're gonna keep doing the algorithm in whatever scenario that happens. We don't really run out in between. It runs in n times n, so basically it runs in n squared. So time complexity would be big O of n squared. There must be a better approach without repeating those steps, those repeating steps. We want to find a way to solve this problem. And this one, we need also to remember that we need to have a low RAM usage, and we need to have a smarter execution plan. That's the optimal goal. That's what we're trying to achieve using this big O notation calculation of measurement. So we need to have low RAM usage and smarter execution plan, fewer steps, but we have a lot of repeated steps. We need to fix this issue, and that's what we're gonna fix next.